Namaskar, I'm Professor Devdip from the Indian Institute of Technology, Bombay. Welcome to this module of our course. Before you get into the module itself, just to remind you, this course is based on the discipline innovation framework, which I've talked in an earlier module, which has got several components to it, starting with identifying a relevant, scalable, meaningful problem which consumers, customers, citizens will pay if you solve that problem. And then is today's module where you develop a compelling product or a solution to that problem which you have identified. And you'll see in the framework, we'll talk about from the very basics to making sure that you can make your product, produce your product, deploy your product or solution at scale. And then in subsequent modules, we'll talk about once you've identified the problem, got a product or a solution, how do you win in the market? And then parallelly, we'll talk about if you have a great research, how to commercialize it. Not necessarily for highest level where you are selling to the government or the army or to large hospital chains, but also to individual farmers, villagers, citizens, women, underprivileged, challenged, children, etc. So how to translate high-tech research for the good of the country, good of the people, create new products. How do you assess your technology, commercialize your technology? And of course, we'll end this course with providing you with a toolkit, an AI-assisted toolkit and a capstone project. So today's module is about product development. And again, it's a structured approach, a very structured approach, step-by-step approach, and we call it the 8P framework. All of this is based on the discipline innovation. And I've talked several times and will keep reminding you about why and what is the Discipline Innovation Network. So, and here are the quick look for all the key elements. We are now in the key element number 2, product development. In this lesson, we will talk about product development. And we'll cover what are the challenges of product development? And then we'll talk about the opportunities and then a structured framework by which faculty or research labs or corporates can actually develop successful products. We'll talk a little bit about the usage and the benefits. We'll talk about the skills and we'll talk about how to drive adoption of this structured framework. What are the challenges and then what are the opportunities related to product development? So some years back, Nielsen, which is a global market research agency, had done a study of successful product launches or the rate of product failures in India in the consumer goods category. And this was widely publicized, and I have shown the news clip there. And amazingly, what they found was that almost 99% plus of products, which will be about 16,000 plus products, over a period of 5 years, actually did not do well in the market. So clearly there's an issue and a challenge around product development. Again, this is another area which you can discover and reflect. There's plenty of material on the internet. So Clayton Christensen, who is a very accomplished Harvard professor and an author of books which you can see on the side, The Innovation Dilemma and then the innovation solution and some others, he went to research and discovered that almost 95% of new products actually don't do well. And this was over tens of thousands of products that he looked at. Again, I would recommend this to spend some time looking it up in public source documents in the internet and reflect on why do you think new products have such a high failure rate. If you're an entrepreneur, I think it's well known that most startups struggle to do well. But the reason is why. And there's plenty of research on the internet, and I'd like you to again discover and reflect why startups fail. And this is a well-known research from CB Insights. And the biggest reason that they found why startups fail was that the startups created brilliant product which nobody wanted, which means there is no demand for the product. So if you put it all together, you may want to reflect, what is it that it takes to make successful product launches, whether you're working for a company, you're a brand manager or an R&D manager, or you're an entrepreneur, or you are a faculty or working in a research lab to create new products. Let's continue with our discovery and reflection process. I will share a few case studies which are very well known, and there's a lot of material available in the internet or open source. And all of these cases are basically to help you do your own research, discover and reflect. And all of these cover different aspects of product success or product failure. Let's start with the product definition itself. And there's three well-known cases of big products, big brands, raised a lot of money, but did not do well. First is a juicing machine called Juicero, which wanted to make juicing, which means a fruit or a vegetable juice making, simple. So it was associated with healthy living. But it struggled and then it failed. Then there was the Segway, which was the personal mobility option. Again did well for a while, and then it struggled, and now it's hardly used. Quibi, very high profile startup for short content duration. Again it struggled, though it had very illustrious founders, and I encourage you to reflect on what these products indicate about the problem definition itself, be it the juicing, be it the personal mobility, be it the small format content. Let's look at a few more aspects of product development, and I will highlight a few cases which you may want to research for yourself and reflect. And these are well-known products from well-known companies. So if you look at Google Glass, it was a very high-profile launch, but it struggled to do well, and today hardly anybody uses it, because the way the product was defined created some concerns around privacy and usage, etc. Similarly, if you go on to Samsung, the early Note series, which was actually the big screen and with a stylus, and again, it has not taken off, and today it has been incorporated not as a separate Note, but into the mainstream S23 Ultra or S24 Ultra or the S22 Ultra. In fact, I use one of them. If you look at Microsoft Zune, which was a music player, again it struggled, versus the iPod and other better established product music players. And again, these are good examples for you to discover and reflect around what did they not get right about the product functionality and the product form. Moving on, let's look at some more very famous examples of very big brands, big companies struggling to the extent that some of them actually died. Nokia was dominating the smartphone, but it is using phones with a keyboard. Unlike today's big screen smartphone, which is swipe based, it had keyboards. And it kept building better and better phones with keyboards, and it chose a certain operating system called Symbian, but that Symbian did not allow for an ecosystem of applications which Apple and Android allowed. And it did not allow for the swipes, etc. And therefore that OS, the operating system of that phone, was actually a liability for the Nokia phones in general. So selection of technology, be it the OS, operating system of Nokia phones, or BlackBerry, which was an email machine, again used by company executives to send a lot of emails, small screen with a keyboard, so you could write a lot of emails on that. And the claim was it was very secure. But again, as the customer and the choices moved towards smartphone with swipe and on-screen keyboard, both of these companies and product struggle. And then the classic case of Kodak, which was a leader in the film photography. But as cameras moved from film-based cameras to digital cameras, this famous company called Kodak did not adapt to the technology. And therefore today hardly anybody actually uses a Kodak film. So the third aspect of product failure is, are you working of the right technology? Even if you get the design right, a lot of times when you make a prototype of complex products, especially technology products, one can face a lot of challenges, and I have tried to put up a few cases which you should research, discover, and reflect on. The very well-known cases from very well-known companies and well-known products. Boeing, which is one of the most famous, market largest aeroplane manufacturers, had a lot of challenges on the Boeing 737 MAX, because when they're testing it out, probably there are some flaws, and later on a lot of defects and challenges came to the fore, which is now quite well publicized. If you look at Google+, that was the attempt at actually social media to compete with Facebook, etc. Today hardly anybody uses Google+. The Amazon Fire phone. Amazon came up with a phone, but when they were designing the phone and testing the prototype, they faced challenges, and today actually the Amazon is not known for its phone at all. So design, prototyping, when you are at the early stages of technology validation. Moving on from the product design, prototyping, testing, coming back to the commercial aspects, there is an important aspect of product development, which is the price, cost, benefit analysis. For example, before I go to the examples on the screen, if you look at Rolls-Royce, it is at a price point and offers certain benefits. And it costs a certain amount of money to make. So Rolls-Royce at the top, and it could be any of those luxury cars. But then you look at the mass sedans or the hatchbacks, be it the Indian ones like Maruti or the Korean ones the small hatchbacks from Hyundai or the Japanese ones or some of the smaller European cars. Clearly, there's a big price, benefit, cost difference between different segments. It's very important to get that right as you develop your product itself. And these are some cases which you may want to discover and reflect on. HP, which was well known for its printers, etc., and computers, okay, tried to compete with the iPad and probably did not get its price cost benefit right versus the market leading Apple or the Samsung. Same with Sony Betamax versus VHS. This is a 80s, 90s case study where there was a challenge between which format of videotapes will the industry adopt. And Sony had its Betamax and a few other companies had the VHS, but VHS could actually record for longer times. And therefore, the price cost benefit ratio of a longer recording tape format called VHS took over Betamax, though Betamax was actually backed by a very famous, very large, very successful company called Sony. One of the great aviation case studies around Concorde. Concorde was a supersonic passenger liner which could cross the Atlantic and go from London to New York in the fastest possible time. But again, it did not do well and survive long term versus a Boeing or the Airbus that we see all around us today, because the cost benefit and price of the for the passenger, price of the aeroplane itself was probably not sustainable in the market space. And therefore, as you design products, it's very critical to look at the price cost benefit ratios. Assuming you've got the design right, you've tested the prototypes, you've got the price cost benefit and the product and the pricing correct, and you've started selling, you still need to be able to service it and make sure that you're producing enough number of products with the right kind of quality. And you can see on the screen a few examples which you should research and reflect on. And one of the cases was Ford. The Pinto, what happened was that Ford launched a small hatchback when there's a lot of small cars coming into US from other countries like Europe, but it had quality issues. And then over time, it did not succeed. Same with another product that I've mentioned at the bottom, which is the hoverboards, okay, which was again a personal transportation, but it had a lot of safety issues. So serviceability, quality issues. And then if you look at the Samsung folding phones, the phones, which is about a few years back, where you could actually fold the screen and open it, actually the first generation had a lot of problems around the hinges, etc. And or when you opened it, you could actually see the line between it. Now, of course, they've improved it. But all these case studies make you aware that even if you get the design and the price cost benefit analysis right, you have to be able to service it and make sure that there's enough quality in it. Moving on. Once you have designed the product and you have made sure that it's serviceable, etc., now you have to produce it to scale. You have to make your products in millions, tens of millions, and if it's a mass product, maybe in billions. And the question is, can you scale? And therefore, the product itself needs to lend itself to scale. And there's some famous case studies which you should investigate in the internet, in the open domain, look it up in terms of papers, and reflect. One of the case studies that you may want to research is on Fisher Automotive. And it made the early generation of electric vehicles, but which did not do well because it could not be produced in sufficient numbers for right amount of safety and quality. Nokia also had a phone which I used to use called Engage, but it had problems. Even the piece that I got had a problem, and apparently they were having difficulties in scaling it up because there was some folding mechanism, etc. Even Tesla, in the early days, and not surprisingly, as they were scaling up production, had challenges around the production side. So as you move further and further on the production cycle of your new product, you need to make sure that the new products can be produced to scale and to quality. So one of the last aspects, assuming that you've got a product which is well designed, well priced, the costing is right, it's serviceable, it's quality, and now we're going global. And you're really now creating your new plants. The watch out now is to make sure that those factories and plants that are producing these in large quantities can maintain those quality standards that you wanted or you had put it into the design itself. And again, these are some case studies that you may want to research on. Jawbone at the bottom, the essential phone, and then you have the Lily drones. Now that you've talked a lot about the challenges, and I've shared a lot of case studies for you to research and reflect, the flip side of a challenge is actually the opportunity. And there are always opportunities for a new product. So why is it that there is always an opportunity for a new product if you look at it from a systemic point of view? So here is something that I would like you to reflect on, and this is the concept of a product life cycle, which essentially means that all products have a certain life cycle from where it starts to where it peaks and then where it generally declines, because new products and new technologies are always coming on stream. And this product life cycle actually offers startups, entrepreneurs, companies, research lab, faculty, and researchers to develop new products, because inevitably the product which dominates today may or may not survive tomorrow. So let's deep dive into a typical product life cycle. So if you look at any product, and I'll give you a couple of examples later on. First, it's a very new product. Very few people know about it. It's only the few consumers and customers who's always looking out for something new, something novel, who will come and probably try it out. And then slowly the demand builds up. But as the demand builds up, and assuming you are the first or your company is the first one which launched the product, more and more companies come in. So the whole category itself expands because there are more players. But as the players compete, slowly maybe the profits and the prices start coming down. And then a new technology comes in. You can still extend the life of the old product cycle for a while, but invariably as new technologies, new product come in, it declines. Let me give you an example. So when I was young, very young, the only music I could listen to was on the radio, because there's no way to store the music. And then we bought a record player, a vinyl record. And there's a disc which is this big, will probably store 2 or 3 or 4 songs. And you could play it, but a big disc like this will probably run for 15 or 20 minutes. And then the tape recorder came in. And you had first the big spools, which is about this big, and this bigger spool of tape could run for about an hour to 2 hours. And then the small tape recorders came in, which are in cassette form. But as the tape recorders came in, the record players started to decline. So this went on for a decade or so, and then MP3 music, digital music started coming on, and digital music could be stored on an audio CD. And then slowly the CDs started replacing the tapes, which has started replacing the record players. Then once you had the CDs, then you started having DVDs, which are actually a better version of the CD. It looks the same, but it could have better music played for a longer time. You could still not carry them with you because the CD player was still big. You could not put it into a pocket. And then digital players with flash memory started coming in. Apple brought in the iPod, and some other small players started coming in. And for the first time, you could actually have a device which is this small, carry it in a pocket, which could store maybe 4, 5 hours, 8 hours of music. Of course, you had to listen to it with a headphone. So record players, records went up, came down, tapes came in, declined, audio CDs, audio DVDs came in, declined, the MP3 in a pocket came in, till the MP3 got incorporated into your smartphone. So Apple started doing that. So the iPhone also had built in the music capacity. You could store the music. But they also launched the iTunes. And suddenly the music could be stored in the cloud. And you could actually choose and play whichever music you want on your smartphone. You could either carry it in your smartphone memory or download it from the cloud. So audio CDs started dying, and the small iPods, MP3 players died, and then you could carry your music in your phone. So you did not have to carry two devices. Now look at the way you consume music today, or I consume music today. We are actually on platforms, Ghana or Amazon Music, Geo Music, etc., where you've got millions of songs which are curated and playlists, etc., and you don't have to carry anything at all. You could just play it off your phone. And then if you look at it, what's now coming are the smart watches. So I have a smart watch where there is a music already, because it also allows you to play. So you don't even need a phone. You got a smart watch with an LTE connection. You could actually play the music on your watch. What this basically means is that every product has a life cycle. When it starts, it peaks, and then a new product form and a new product company comes in, and that is the opportunity for new product development. Underlying the new product development is the evolution of technology. I just described to you how the music industry has moved from one version to the other. The same thing is happening in cars. We have moved from combustion engine to electric vehicles. And we have moved from trains to hyperloops, trains, bullet trains, hyperloops, etc., moving towards there. So companies like Gartner are always creating and predicting how new technologies are coming in. So if you look at the screen, you will see the technologies which are coming in. So if you look at the curve, some of the technology are still emerging. For example, ChatGPT or Gen AI, generative AI or large language models, they're about 12 to 18 months in the public domain. But they're very quickly evolving. So ChatGPT 3, 3.5, 4, and now we've got 4.0. And by the time you're watching it, you'll probably get onto ChatGPT 5. And then more and more users are coming in, be it in hardware, be it in software, be it in biotechnology, be it in drones, be it in robots, be it on mobility, be it on healthcare, be it on any domain. And as these new technologies emerge and they mature, they drive new product development. And that is an opportunity. And if you look at the screen again, look out for new technologies that emerge. Industries change driven by technology. And let me give you an example of advertising. So when the Gutenberg press came in, and suddenly knowledge could be printed on paper, and books were started to being produced, the advertising industry started with flyers and pamphlets on which you could advertise a product. Once radio came in as a technology, radio jingles came in because those are the advertising. And many of you would have heard and still be hearing advertisement on your FM radio. Similarly, when telephone came in, telemarketing came in. People would call up and advertise their product. Then when television came in, television TV advertising came on. So from paper to telemarketing to radio marketing, radio jingles to television. And then we had social media. And once you had social media, Facebook or Instagram, social media advertising came in. And now we've got all these OTT platforms, and all these platforms, there is advertising. So as the technology evolved, industries evolved. I talked about music, and I just talked about advertising. And that's why any of you who are doing product development need to keep an eye on what are the new platforms, new technologies that's coming in, based on which you could launch a new product. And if you are working on really sophisticated product like in defense, like in space, like in genetics, or drones, the next gen drones, or implants, if you're looking at the long gestation, molecular kind of development, product development, like the vaccine, the COVID vaccine, some of the new vaccines that are being worked on, the new molecules that are being developed, okay? Keep an eye out on technology that's coming out of IITs or MITs or Oxford or Cambridge or some of the universities around the world, because those are technologies which are in the lab today, but may be commercialized in product form in 2 or 3 years after they've come out of the lab. So far I have talked about product challenges and product opportunities. The big question now is, how do you have a structured framework to develop new products? Let me talk you through an approach. So now that I've looked at the challenges and the opportunities of product development in the real world, with many large companies, large products, we looked at the data, how do we, be it in an R&D setup or a brand management setup or a product management setup or a research lab in academia or in industry, how do we put it all together in a framework for product development? And I would submit that there are 8 steps, I call them the 8P of a product development frameworks. Let's look at what is this framework. So if you look at the framework, it starts with the product design, and there are 4 Ps to the product design work. And then if you look at the right side, there are the 4 Ps or the 4 components of product development. So there's design and there's development. Let's deep dive on the design side. So let's look at the framework with the 8 different steps or components. I call it the 8P. So on the left side, you look at the components for product designed. And on the right side, once you've got the design right, how to develop it to production and scaling. The first clear step, of course, is to make sure that the problem itself, the unmet need of the customer or the country or defense or space is clearly defined. And in the previous lesson, I had talked of the 8C problem discovery framework. So it starts with defining the problem in enough depth, relevant, scalable, urgent manner. Once the problem is well defined, the key now is to have the product form, functionality defined from the user point of view. There's no point having a product which is so complex that the user cannot use it or the form is inconvenient. The smartphones are extremely sophisticated pieces of computing machinery, but they're very easy to use. So how do you create a brilliant functionality in a way that customers can find it easy to use? Once you've got that defined, the next question is, what is the underlying technology? What makes it work? For example, if you have a great functional website to perform a certain task, what then is the underlying technology to make the website function? Or if it's a drone, or a robot, or a PlayStation, you've got the functionality, you've got the joystick, you've got the controller. Question is, what's the underlying technology? How do you make a complex technology easy to use by the user? And of course, the fourth P would be around, even if you get a brilliant piece of technology into a very simple to use format to solve a very specific problem, how do you get the price cost benefit ratio right? Because that's where a lot of external benchmarking comes in. And if you look at the Concorde plane, definitely it was a brilliant piece of aviation technology and got you there faster than any other plane from London to New York. But the price cost benefit ratio probably did not work for the airline or for the passengers maybe. And therefore, as a product form, it did not stand the test of time. Now, assuming you've got the design right, then the next step is, how do you make sure that you can produce it in scale, in quality? And therefore, the first thing is to make sure that all the design is actually prototyped and tested in stages. And you may start with a small technology validation in a lab, and then you have to create a first prototype which can be used by users, but probably doesn't have all the bells and whistles. So it's a simple prototype, an alpha prototype. And then once the customers come back and say, oh yeah, we like it, and it solves the problem for us, how do you then go to a more sophisticated, finished-like product? And then actually the product that will put into the market, the first few pieces of the production-grade product. But even as we're doing all of these, one still needs to think about the producibility and the quality. Quality in terms of testing and meeting the standards of food safety or FDA, etc. One can make 10 pieces, 20 pieces, 1,000 pieces, 10,000 pieces with quality. But the moment one needs to make millions of pieces, and not in one plant, decentralized plant, one in the US, one in China, one in India, producibility and quality becomes very, very important. And then the flip side of that is, what does the production process look like? Again, to go back to some of this complex consumer technology, be it a car, electric car, self-driven car, be it a laptop, be it a smartphone, be it a new generation TV, it has got a huge amount of components which are probably made from across the world. So there may be a screen which comes out of Korea, there may be a chip which comes out of Taiwan, there may be electronic components which comes out of Japan, the whole assembly may be done in India or China, and the product may be shipped to US for consumption. Question is, how do you manage this whole production and assembly processes where you're pulling in components from around the world? And think about making an aeroplane or a spacecraft. So how do you make it producible and make sure that the production line takes into account feeding components from around the world? And then, of course, as the demand grows, you have to create bigger and bigger and bigger factories and run more lines. And even if it's a simple product, like a beverage, a bottle of beverage, you may start with a line which is 300 bottles per minute. But as demand grows, you may have to take it up to 600 bottles per minute, or 900 bottles per minute, or 2,000 bottles per minute. So suddenly, the production is scaled, even if it's the same plant and the same product. But the speed of the assembly line has gone up. So how do you ensure all of that? So if you put all of this together, this is probably a framework which will help you start thinking from the problem to the functionality, to the underlying technology, to the price cost benefit. And then on the right side, how do you create millions of these pieces, maybe around the world, more and more, faster and faster, but maintaining the standards and the quality and the serviceability. And this together may be a production framework, a product development framework that you may want to look at. Let's deep dive into some of these components of this framework.